This item was already used when solving for the foot of the perpendicular. Given here the line expressed as -2 and 1 plus your direction vector 5 and 2, and x, which is not on the line, which is 2 and -3. You also place here the same scribbles on our Cartesian plane because we are also going to talk about some of the concepts here. Take note that the point F identified and all the scribbles at the bottom as well are in actually 2 and over 29 and 53 over 29. That's actually here, this portion here. Let me change the color, probably point here. Okay, and our x is this one. So we're going to solve now for this video the distance of that said foot to the same x. The distance for the foot of the perpendicular to the x is actually the shortest distance from that point and the line. Now, we were able to solve the foot actually using this formula at the bottom, but this formula for the foot already contains the distance to from the point x to the foot of the perpendicular. You can actually just attack it once and you can get two different values. Number one is the foot of the perpendicular, and the second is, again, the purpose of this video, the distance of point x to the foot. Take use of this portion here. This is actually the distance of x to f, where x is the point not on the line and f is point on the line, specifically the foot of the perpendicular. So we actually take the inner product of x minus p and the normal unit vector or unit normal vector. Okay, but since discussed as well that the distance or this inner product may take negative values depending on the components of our points x and the foot of the perpendicular, that's why the formula for distance is actually the absolute value of that. So if you were able to solve for the foot of the perpendicular, simply look at your scribbles, and we will be using this so that we will be saving time. That is actually equal to this portion here, which is illustrated to this, later on connected to this, which is just equal to, okay, the value of -28 over 29. This is the value of the inner product. So you will have here the result, which is actually, sorry for that, okay, it is actually -28 over square root of 29. But then again, the distance is on the absolute value, so you will get here 28 over square root of 29. If you would like to rationalize that, square root of 29 over square root of 29, you will get the distance from point x, which is 2 and -3, and f, which is this one here, value, is actually 28 square root of 29 over 29. So this is actually the distance of the point x to the foot of the perpendicular, already solved in one of the videos. So if you are not yet convinced with the foot, you can always review the video discussing the foot of this perpendicular in that specific video pertaining to this alone. Thank you very much for watching.